Hashed. Understanding the unit circle. Using a clock face. Imagine a clock face with the center as the origin. The distance from the center of the clock to any hour mark is always the same, and this distance is called the radius. Using this familiar clock, we will explore angles and how they are measured in both degrees and radians. Additionally, we'll explain how the coordinates at each point relate to trigonometric functions like cosine and sine. What is a radian? A radian is a way to measure angles based on the radius of a circle. Imagine the minute hand of a clock. Its length represents the radius of the circle. If you could bend this hand so it wraps perfectly along the outer edge of the clock face, the length of the bent hand would mark 1 radian. It takes a little more than 6 of these bent hands to cover the entire edge of the clock, making a full circle equal to approximately 6.28 radians, or exactly 2 times pi radians. Angles and trigonometric coordinates around the clock. The coordinates at each clock position represent the cosine and sine of the angle. The first number in the coordinate pair is cosine, which measures the horizontal distance from the center to the clock hand's position. The second number is the sine, which measures the vertical distance from the center to the clock hand's position. 1. 3 o'clock, 0 degrees or 0 radians. At 3 o'clock, the clock hand points directly to the right. This is 0 degrees or 0 radians. The coordinates are 1, 0, where 1 is the cosine, horizontal distance, and 0 is the sine, vertical distance. 2. 12 o'clock, 90 degrees or pi divided by 2 radians. At 12 o'clock, the clock hand points straight up. This is 90 degrees or pi divided by 2 radians. The coordinates are 0, 1, where 0 is the cosine and 1 is the sine. 3. 9 o'clock, 180 degrees or pi radians. At 9 o'clock, the clock hand points directly to the left. This is 180 degrees or pi radians. The coordinates are -1, 0, where -1 is the cosine and 0 is the sine. 4. 6 o'clock, 270 degrees or 3/2 pi radians. At 6 o'clock, the clock hand points straight down. This is 270 degrees or 3/2 pi radians. The coordinates are 0, -1, where 0 is the cosine and -1 is the sine. 5. Back to 3 o'clock, 360 degrees or 2 pi radians. Completing the circle brings you back to 3 o'clock. This is 360 degrees or 2 pi radians. The coordinates are 1, 0, where 1 is the cosine and 0 is the sine. Key intermediate angles and their coordinates. To describe the angles between these main positions, let's explore the intermediate points on the clock face. The coordinates for these points involve the square root of 2 divided by 2, which is approximately 0.7. 1, 130, 45 degrees or pi divided by 4 radians. Picture the clock hand halfway between 12 o'clock and 3 o'clock. This is 45 degrees or pi divided by 4 radians. The coordinates are square root of 2 divided by 2, square root of 2 divided by 2. These are approximately 0.7, 0.72. 2. 430, 135 degrees or 3 pi divided by 4 radians. Picture the clock hand halfway between 12 o'clock and 9 o'clock. This is 135 degrees or 3 pi divided by 4 radians. The coordinates are negative square root of 2 divided by 2, square root of 2 divided by 2. These are approximately negative 0.7, 0.7. 3. 730, 225 degrees or 5 pi divided by 4 radians. Picture the clock hand halfway between 6 o'clock and 9 o'clock. This is 225 degrees or 5 pi divided by 4 radians. The coordinates are negative square root of 2 divided by 2, negative square root of 2 divided by 2. These are approximately negative 0.7, negative 0.7. 4. 1030, 315 degrees or 7 pi divided by 4 radians. Picture the clock hand halfway between 6 o'clock and 3 o'clock. This is 315 degrees or 7 pi divided by 4 radians. The coordinates are square root of 2 divided by 2, negative square root of 2 divided by 2. These are approximately 0.7, negative 0.7. Why use radians? Radians are a natural way to measure angles because they relate directly to the circle's radius. If you take the length of the radius and bend it along the edge of the circle, that length becomes 1 radian. A full circle is 2 pi radians because the circumference of a circle is 2 pi times the radius. Summary of angles around the clock. 3 o'clock, 0 degrees or 0 radians, coordinates 1, 0. 12 o'clock, 90 degrees or pi divided by 2 radians, coordinates 0, 1. 9 o'clock, 180 degrees or pi radians, coordinates -1, 0. 6 o'clock, 270 degrees or 3/2 pi radians, coordinates 0, -1. Intermediate angles. 130, 45 degrees or pi divided by 4 radians, coordinates square root of 2 divided by 2, square root of 2 divided by 2, 430, 135 degrees or 3 pi divided by 4 radians, coordinates negative square root of 2 divided by 2, square root of 2 divided by 2. 730, 225 degrees or 5 pi divided by 4 radians, coordinates negative square root of 2 divided by 2, negative square root of 2 divided by 2. 1030, 315 degrees or 7 pi divided by 4 radians, coordinates square root of 2 divided by 2, negative square root of 2 divided by 2. This revised explanation should now be fully corrected. Quadrants and sines of trigonometric functions. The unit circle is divided into 4 regions called quadrants, based on the directions of the x-axis and y-axis, moving counterclockwise around the circle. 1. First quadrant, 0 to 90 degrees. Both x cosine and y sine coordinates are positive because they are measured to the right and upward. 2. Second quadrant, 90 to 180 degrees. The x-coordinate cosine is negative because you are moving left, but the y-coordinate sine is still positive because you are still above the x-axis. 3. Third quadrant, 180 to 270 degrees. Both x cosine and y sine are negative because you are moving left and downward. 4. Fourth quadrant, 270 to 360 degrees. The x-coordinate cosine is positive because you are moving to the right, but the y-coordinate sine is negative because you are below the x-axis. Symmetry of the unit circle. The unit circle is symmetric across the x-axis, y-axis, and origin. This symmetry helps explain the signs and values of cosine and sine. 1. Symmetry across the y-axis. Cosine values, x-coordinates, are mirrored but take on opposite signs. For example, cosine of 30 degrees is the same as cosine of 150 degrees, except that it is negative in the second quadrant. 2. Symmetry across the x-axis. Sine values, y-coordinates, are mirrored but take on opposite signs. For instance, sine of 30 degrees is the same as sine of 330 degrees, but negative in the fourth quadrant. 3. Diagonal symmetry. For angles like 120 degrees and 60 degrees, the values of sine and cosine are swapped due to their position in the second quadrant. Specific angles. 30 degrees, 60 degrees, 120 degrees, and 150 degrees. 30 degrees, first quadrant. The angle is in the first quadrant where both sine and cosine are positive. Coordinates. Cosine, horizontal distance, is square root of 3 divided by 2, approximately 0.8666. Sine, vertical distance, is 1/2, approximately 0.5. 60 degrees, first quadrant. The angle is also in the first quadrant where both sine and cosine are positive. Coordinates. Cosine is 1/2, approximately 0.5. Sine is square root of 3 divided by 2, approximately 0.66. 120 degrees, second quadrant. The angle is in the second quadrant where cosine is negative, moving left, but sine is positive, still above the x-axis. Coordinates. Cosine is -1/2, approximately -0.5. Sine is square root of 3 divided by 2, approximately 0.866. 150 degrees, second quadrant. The angle is in the second quadrant where cosine is negative, but sine is positive. Coordinates. Cosine is negative square root of 3 divided by 2, approximately -0.866. Sine is 1/2, approximately 0.5. Why cosine is negative in the second quadrant. In the second quadrant, the angle corresponds to moving to the left of the origin. On the unit circle, the x-coordinate cosine is negative because the point is left of the y-axis. However, the y-coordinate sine remains positive because the point is above the x-axis. For example, at 120 degrees, cosine is negative 1/2 because the horizontal direction is to the left, but sine is square root of 3 divided by 2 because the vertical direction is upward. Negative signs in the third and fourth quadrants. In the third and fourth quadrants, third quadrant, 180 to 270 degrees, both x cosine and y sine are negative because the point is to the left of the origin and below the x-axis. 2. Fourth quadrant, 270 to 360 degrees, cosine x-coordinate is positive because the point is to the right of the origin, but sine y-coordinate is negative because the point is below the x-axis. Symmetry and reflection for these angles. 1. 30 and 150 degrees. The coordinates for 30 degrees and 150 degrees are the same in absolute value but opposite in sign for cosine. This is because 150 degrees is symmetric to 30 degrees across the y-axis. 2. 60 and 120 degrees. Similarly, the coordinates for 60 degrees and 120 degrees have the same absolute values, but cosine changes sign. This is due to the symmetry across the y-axis. Recap of coordinates. 30 degrees, square root of 3 divided by 2, 1/2. 60 degrees, 1/2, square root of 3 divided by 2. 120 degrees, negative 1/2, square root of 3 divided by 2. 150 degrees, negative square root of 3 divided by 2, 1/2. By understanding quadrants, symmetry, and the relationships between angles, you can predict the signs and values of trigonometric functions for any angle.